Subscribe my channel for physics, JEE and NEET.
Hello students, good morning all of you. Today in our class, I need to explain class 11th ka chapter, that is center of mass. About the center of mass, the chapter name it is system of particles and rotational motion. System of particles and rotational motion. Right? So before going to that, you have to subscribe my channel and like, share to your friends. Okay, let us start our topic. System of particles. System of particles, rotational motion. Rotational motion. Right. So in our daily life, so many objects are in our hands. Okay. Every object can consisting so many of particles. So many of particles. So that is the system. The system, it is nothing but the group of elements. The group of elements in a particular region. That is the system. So every body or every object is consisting some particles. Okay, so here in this, the objects are at first rigid bodies, rigid and non-rigid. So rigid body, it is meaning that, what is the rigid body? A rigid body can consisting, whenever we have to applying an external forces on a body, that cannot be changes its shape. That bodies are known as rigid bodies. The particles are bounded with strong bonds, and the density of the particles are heavier. Then the body will not changes its shape. Right? So that is the rigid body. And coming to the non-rigid body, by the external forces, the body can easily change its shape. So one more thing you have to remember here, there is no perfect rigid bodies in the universe or nature. There is no perfect body. Of course, this is a body, whenever I have to apply an external force, it will not change its shape. But I want to apply more force, right, like hammer, iron hammer, then it will be breaks. So at any much of force will be acting, the body must be changes its shape, right? Until that it is a rigid body. So here there is no perfect rigid bodies in the nature. Okay, and right, coming to the center of mass of the system. A rigid body can consisting three types of motion. That is translational motion, and the second one it is rotational motion, and the third one it is rolling motion. Translational, rotational and rolling. These three are the motion of the objects. So what is meant by translational motion? In a translation motion, all the particles are moves with same velocity. For example, a body having the mass m is sliding on the incline. So this can having the translational motion. So this is the translational, right? So all the particles in this body must have the same velocity. And second one it is rotational motion. So that is nothing but it is a fan. So fan which is rotates with an axis. So that is the rotational motion. And coming to the rolling motion, if your body can be rolls, on a inclined. If your body can be rolling, if your body can be rolling on a surface of the incline. So it is the rolling motion, and this is the translational, and this is the rotational motion. So these are the motion of a rigid bodies. So this motion should be depends on the center of mass of the bodies. Center of mass of the bodies. Let us see the center of mass of a body. So whenever we have to project a body, that body can follows the path of projectile. That body can be follows the path of parabola, right? So that is, if we have thrown an object with certain angle, it's a certain angle to the horizontal, right? And then that body, so this is the mass of the particle, this is the body which you have to thrown, and that body should be follows, this is the path of the body. So this can be shows the shape of parabola. So here all the particles having the center of mass, the direction of the center of mass is which direction, that is the path of the system. So this body has a system, and all the molecules are moving along with the center of mass of this system, right? So how we can define the center of mass of a body? So that is very important. Center of mass. So center of mass, it is COM. Shortly it has COM. The total mass of the body, at which point it will concentrate, it will locates, is called COM, is called center of mass. The total mass of a body at which point it will locates is called center of mass of a system. At the center of mass of a system, the total mass of the body should be present there, should be concentrated there. That is the center of mass of the system. For suppose the center of mass of a circular ring. So this is the ring. So this ring has the center of mass at the center point. So here one question we have to learn, that is that at the center of mass of a system, there is not necessary to present the mass. Here no mass. So no mass should be present at the center of mass of a system. Is it not necessary? It is not necessary, right? It is not necessary to having the mass at the center of mass of a system. Right? And one more we have. This is a disc. This is the circular disc having the center of mass at the center point of the disc. And we have to take a square. It has the center of mass of all the bisectors. At which bisector is there, that is the center of mass. And we have to take a triangle. At the centroid. It has the center of mass. Okay. In case of rectangle, it has the center of mass of the bisector. In case of cone, this is a cone. So it has the center of mass at the 3h/4. It has the center of mass at the point of 3h/4. This is the cone. This is the square, and disc, circular disc, and triangle. and it is the rectangular. Okay, so this is the circular ring. So these are the different materials having the different parts of center of masses. Different parts of center of masses. Okay. So here one point we have to remember, at the center point of at the center of mass of a point, there is no mass, there is no need to present the mass. There is no need to present the mass. Okay, clear? So how we can define the center of mass of a system with two particles? The center of mass of a system with two particles. So let us see. See the center of mass of two particles of a line. So the center of mass of two particles the center of mass of two particles of a line. Okay, let us see. So here let us consider two particles are in the same line having the mass m1 and m2 with certain distance. The distance between the two particles are some distance, and how we can find the center of mass of the system, let us see. So here there are two particles. So this is the one of the system we have to assume here. This is the point origin, and this is the x-axis, and this is the y-axis. At this point, so here there is a particle which is having mass m1, and here another particle having the mass m2, m1 and m2, right? So here we have to assume that the distance between these 2 points, it is d. The distance between these 2 points is d. The center of mass between these 2 points, it is C here. The center of mass between these 2 points is C. The distance from the mass m1, it is r1 from center of mass. The distance from the mass m2 to the center of mass, that is r2. So here you have to know that d is equal to r1 plus r2. So here the m1 particle is distance located from the origin, that is the x1, and the center of mass of your particles, is xcm distance. This is the center of mass. The second massive particle, that is m2, having the distance from the origin, that is x2. So this is the origin. Okay, so these are the distance. The first particle is x1 distance from the origin. The center of mass, it is xcm distance from the origin. The second massive particle is x2 distance from the origin. Clear? Right. So here the center of mass of the system is definitely nearer to the heavier mass of the two particles. Which is the heavier mass of a particle? The center of mass is nearer to that point. For suppose, if 2 kg and 4 kg masses are separated in a distance, the center of mass must be nearer to the 4 kg massive particle. Okay, and also the distance and to the mass, is inversely proportional to the massive particle here. So here the distance of the center of mass is inversely proportional to the mass of the particle. So this is the rule you have to remember, very important. Okay, if the mass is less, the distance is more. For suppose here there is 1 kg body and here there is 5 kg body. The center of mass must be at the distance of, so here there is 4 meter at first. The center of mass must be at 3 meter. At 3 meter. 3 meter is nearer to the 5 kg body. Because of the total distance between these two, it is the 4 meter. The center of mass is located at the 3 meter. The center of mass must be nearer to the heavier body, heavier massive particle. So, if the mass is less, the distance is more. This has the less mass, the distance is more. Okay, how much distance it has? 3 meter. So here just I am taking an example with 1 kg and 5 kg, it is not exactly. So if mass is heavy, the distance is less. That is nothing but the distance from the center of mass and to the heavier mass, it is here only 1 meter. Right? So because of the mass is very high. Right? So that is the relation we have to remember here. From this we can write that R1 by R2, it is equal to M2 by M1 because of it has inversely proportional. From this we can write that M1 R1 it is equal to M2 R2. M1 R1 is equal to M2 R2. So from this we can write that R1 and R2 are the distances of the massive particles from the center of mass. Right? So from this figure we have to write R1 it is equal to, so this is the center of mass and this is the distance of the x2 and this is the center of distance of the m1 particle. Right, R1 it is equal to, R1 you can write that, what is that R1? xcm minus x1. So from this distance we have to subtract this distance, we have get this one. So xcm minus x1. Clear? And similarly R2 it is equal to, you can write that. So R2, this distance, it is x2 minus xcm. x2 minus xcm. Let us substitute and d is equal here R1 plus R2. So these are the observations we noted in the diagram. So from this equation you can write that M1 R1, it is meaning that, what is that R1? xcm minus x1, it is equal to M2. What is R2? It is x2 minus xcm. So let us multiply, whereas M1 xcm it is equal to minus M1 x1, it is equal to M2 x2 minus M2 xcm. The cm particles, it is M1 xcm plus M2 xcm, it is equal to M2 x2 plus M1 x1. Clear? This minus M1 x1 it is goes to plus M1 x1. Here xcm is common, where xcm is common, then M1 plus M2 here. This is M1 x1 plus M2 x2. Therefore xcm it is equal to M1 x1 plus M2 x2 by M1 plus M2. So this is the center of mass. This is the center of mass of two particles in a line. So this is the center of mass of two particles in a line. Very, very, very important. So to find the center of mass of two particles in a system. So to find the center of mass of two particles in a same line. In a same line. So this is the center of mass of two particles of a system. Two particles of a system. Right? So let us see how we can find the center of mass of with some examples. Okay. So let us see. So here, so and also we have to write from this, so we can the small d value where we can get xcm it is equal to m1 x1 plus m2 x2 by m1 plus m2. m1 plus m2 it is the total mass. Okay. So from figure we have to write that d is equal to r1 plus r2. Right? Where r1 it is equal to d minus r2 here. So from the equation you can have to m1 r1 it is equal to m2 r2. So from m1 R1 it is equal to D minus R2. It is equal to M2 R2 here. Whereas M1D minus M1 R2, it is equal to M2 R2. Okay. Right. So from this you can write that M1D is equal to M2 R2 plus M1 R2. So R2 is common, M1 plus M2 here. So this is the M1D. So where R2 it is equal to M1D by M1 plus M2, M1 plus M2. So this is the very shortcut method. We have to find the distance of the second particle. This is the distance along with the first particle. So how we can find the center of mass? From the along with the M1, you have to find this tree. So R2 is equal M1D by M1 plus M2. M1D by M1 plus M2. Similarly, so from this point, this massive particle R1 it is equal to M2D by M1 plus M2. So where here we have to subject the R2 value, then D minus R1 we have to put it, then you can get the R1. So these are the shortcut methods. You have to find the distance of the center of masses. Distance of the center of masses, and the distance must be nearer to the heavier mass. Nearer to the heavier mass. If suppose if the particles are same massive particles, if the particles are having same mass, for example, this has 1 kg particle and this has 1 kg massive particle. So masses are equal. M1 it is equal to M2 it is equal to M. Then what is the center of mass? Let's substitute here. So M, x1 plus x2, 2M. So x1 plus x2, xcm it is equal x1 plus x2 by 2. So this is the center of mass of two particles at the center. Now let us see here in this, where it is R1 it is equal md by m plus m 2m. So this is equal to d by 2. So at the center point, the distance of the same two particles are located at center point. Here also, so if m is equal, m1 is equal to m2 is equal to m, then R2 it is equal to d by 2 here. So if two equal masses are along with a line, then the center of mass should be present at the center point. But in case of different massive particles, the center of mass should be present, which is heavier mass nearer to the heavier mass. Right? Nearer to the heavier mass. This is the variation you have to remember here. Okay. If one of the particle has the mass 2 kg and another has 3 kg here, right? So the distance from these two, it is 3 meter. The distance from these two, it is 3 meter. Find center of mass. Find center of mass. How we can find? So here in this pattern, you have to assume this is the origin here. At the origin, the x1, x2 coordinates are 0, 0. At the origin, the x1, x2 coordinates are 0, 0. And here at the x position, it is 3 meter, 0, 3, 0. So from this, we have to, this is x1, y1, x2, y2, where it is m1 and m2. So let us write xcm it is equal m1 x1 plus m2 x2 by m1 plus m2 here. So this is equal, what is m1 here? 2 kg into x1 0 plus m2, it is 3 kg into x2, it is equal 3 by m1 plus m2, 2 kg plus 3 kg, right? That is how much? 3 3s are 9 by 5. It is equal 1.8 meter. 1.8 meter. XCM it is equal 1.8 meter. So whereas 1.8 meter it is equal to 1.5, 1.6, 1.7, 1.8. So this is the 1.8. So at the center of mass it is 1.8, which is nearer to the heavier mass. Which is nearer to the heavier mass. The distance of the R1 it is equal to 1.8, right? So remaining distance it is equal to 1.2. Okay? But simply we can write that. So how we can find the distance between these two? Where it is the M2. So from M2 it is equal, this is the R2. R2 it is equal M2D, M1D by M1 plus M2. This is the shortcut method. M1 it is equal 2 kg here, D it is equal 3 meters here, right? By, right? 2 into 3 meter by 5. It is equal 6 by 5. It is equal 1.2 meter. So this is the R2, which is 1.2 meter. So the total distance is 2 meter. The center of mass is located at 1.8 meter. Remaining distance it is 1.2. So from coming to this side, so the R1 it is equal, where it is R1 it is equal M2D by M1 plus M2. M1 plus M2. Okay. So how much it is? So M2 it is nothing but 3 kg, D it is equal 3 meters and it is equal 5 meters, M1 plus M2. It is 9 by 5, it is nothing but 9 by 5, it is nothing but 1.8 meter, right? So this is 1.8 meter. So this is the shortcut method you have to assume that, right? So this is the pattern you have to find the center of mass of two particles. Center of mass of two particles. Okay. So first suppose, if two iron rods, so it is nothing but, so this is the one of the rod, this is the one of the rod having the length L, and this is another rod having the length L. The lengths are equal, so this is the L. The center of mass of the rod it has locates at L by 2 distance, okay. So this is the center of mass of the first rod, this is the center of mass of the second rod. So how we can find the center of mass of this arrangement? This is the T shape, of two iron rods. How we can find the center of mass of this shape? So here this is the origin, it has 0 0 and this is the L by 2 comma 0. So from this XCM it is equal M1, right? This is the mass M1, okay. So M1, so it has mass M and also it has mass M, let it be. M x1 is equal 0 plus M2 x2, it is equal L by 2 by M plus M, what is that? 2M. It is ML by 2 by ML by 2 by 2M, 1 by 2M. It is equal ML by 4M. It is MM cancel, it is equal L by 4. So the center of mass is at the L by 4. This is the L by 2 and at this point this is the L by 4. The center of mass, this is the CM. The center of mass is located at the L by 4 of distance. L by 4 distance. Okay, how we can find that? In this method. Okay. So here this is the pattern you have to find the center of mass of two particles of a system. Now let us see the motion of the center of mass of a system. The motion of the center of mass of a system. So if at which direction the center of mass should be moving, all the particles are followed by the center of mass. Okay, the path of the center of mass must be in the parabola. So now we have to find the position of a center of mass of the system and the velocity of the center of mass of a system and the momentum of the center of mass of a system and also the acceleration of the center of mass of a system and the forces acting on the center of mass of a system. Okay, so this is the motion of a center of mass of a system, very very important. Okay, let us see. Center of mass, motion of a center of mass, motion of a center of mass of the system. Okay, So here there is a system having so many particles in xy plane. A particle which is m1 at the position of r1, a particle which is m2 at the position of r2, and one more particle m3 which is at the position of r3. The center of mass is c in the distance of rcm, So this is the one of the body we have to assume here, one of the body. Okay, so the total particles are moving according to the motion of the center of mass, So let us see. So the position of the center of mass, it is equal RCM, it is equal m1 r1 plus m2 r2 plus m3 r3 by m1 plus m2 plus m3 here. So this is the position of the center of mass of a particle or of a system. Right, here there are n number of particles are there, n number of particles are present in a system. Then RCM, it is equal to m1 r1 plus m2 r2 and plus up to mn rn by m1 plus m2 plus up to mn. So this is the n number of particles in a system, the position of the center of mass, So now we have to write that. So RCM, it is equal sigma mi ri. So here I, it is equal 1 to n by sigma m. So where it is I is equal sigma mi, here I is equal 1 to n. So this is the total mass of the system. Sigma m, it is summation of m, that is nothing. Sigma m, it is nothing but total mass of the entire system. It is m1 plus m2 plus up to n particles. So this is also right equation. So the replacing of this one. Okay. So now let us, if the displacement, this is the position. If the position will be derivative with respect to the time, the position by time will be gives us the velocity of the center of mass of a system. So now we have to derivate on both sides, with respect to time. Therefore dRCM, d by dt of RCM, it is equal d by dt of m1 r1 plus m2 r2 plus up to mn rn by this is capital M. Because what I am saying, it is the total mass of particles. Individual masses are given to us, total mass of the system. So here d by dt, it is nothing but, what is that here? So dRCM, position by velocity, time, it is nothing but given to us velocity of center of mass, it is equal m1 dr1 by dt, it is nothing but v1 plus m2 dr2 by dt, it is given to us v2, and plus up to plus mn vn by total mass of the system. This is the velocity of the center of mass of a system. So this m should be comes this side, then m into vcm, it is equal m1 v1 and plus m2 v2 plus up to mn vn. So this looks like to seems to us the mass into total mass into velocity of the system is given to us mass into velocity, the product of mass into velocity given to us momentum. So here momentum of the center of mass, PCM, momentum of the center of mass, and here m1 v1 it is equal p1 and m2 v2 is equal P2, and mv it is equal basically momentum, that is P. So from this you can write that PCM it is equal P1 plus P2 plus up to Pn. That is, we have to say here the momentum of the center of mass of a system is equal to the momentum of all the individual particles in a system. The momentum of the center of mass of a system is equal to the momentum of all the individual particles in a system. Okay, so that is the momentum. So now let us derivate this equation on both sides with respect to time. Then the dVcm by dt, the change in the rate of change of velocity, gives us the acceleration of a body. Right? That body it is nothing but here in this system. Right? So we have to write from this equation, whereas we can write m into dVcm by dt, it is equal to m1 into dV1 by dt plus m2 into dV2 by dt and plus up to plus mn dVn by dt. Here we can write that m1 dV by dt it is equal to a1 plus m2 dV2 to v2 by dt it is equal to a2 and plus m a n, where it is dVcm by dt it is equal to acm, that is equal to macm. So cm it is the center of mass. So here the center of mass, the mass into acceleration gives us the mass into acceleration, it is equal to fcm. So by the Newton's second law, f is equal to ma, whereas macm it is equal to fcm. Okay. So fcm it is equal to f1 plus f2 plus up to fn. The force acting on a center of mass of a system is equal to the forces acting on individual particles, the sum of all the forces acting on the individual forces. Right? So here one more point we have to remember. The fcm it is equal, the forces on the center of mass it is equal to f external plus F internal forces, F external forces and plus F internal forces. The internal forces of all the particles, the internal forces, F internal forces, the internal forces of all the particles in a system always cancel to each other. So hence the internal forces should not be acting on the center of mass of a system. Therefore, fcm it is equal to only the F external forces. F center of mass it is equal only F external forces. Okay, so this is the motion of a center of mass of a system. Right? So here, if two particles are moving with the same speed or different speeds in a same direction, so then the velocity of the center of mass it is equal to m1v1 plus m2v2 by m1 plus m2. So this is the velocity of the center of mass of a system if two particles are moving in the same direction. If two particles are moving in opposite direction with different velocities, then vcm it is equal to m1, right, v1 minus m2 v2 by m1 plus m2. So this is the v1 v2 are opposite, and here v1 v2 are same direction. Okay, so this is the formula you have to find the center of mass or the velocity of center of mass, right? So from this we can find the acceleration of the center of mass of a system. ACM is equal to m1 a1 plus m2 a2 plus up to mn an by capital M. Right? So this is the motion of the center of mass of a system. We have to find in different methods. So in our next class we have to discuss the different objects having the center of mass, how we can find that, and we have to give some more examples in our next session. If you like this video, please hit like and share to your friends, and if you have any doubt, please comment in the comment section. So please don't forget to subscribe my channel. So thank you one and all.